State the natural domain and corresponding range of the function f of x is 3 plus 4x divided by x minus 2. So let's think about the domain first. Our only problem with this function would be that we can't have a 0 in the denominator. That would happen if x was equal to 2. No other value is a problem, so we could have all real values excluding 2. The range is a bit more complicated. To work out range, you really do need to know what some of these graphs look like. So, let's consider a sketch of the function. We don't need to get it very accurate, we just need to know roughly what it looks like. The denominator of x minus 2 tells us that we have a vertical asymptote at x equals 2. To get the horizontal asymptote, just think about x tending to infinity, x being a really big number. If x is really big, we can ignore the 3 and the 2, and the function becomes 4x over x, which is 4. That means that y equals 4 is a horizontal asymptote. That's because the 3 and the 2 mean that it can never actually be 4. It will always be a little bit different from 4 because of those values. So, y equals 4 is a horizontal asymptote. The graph is a transformation of y equals 1 over x, and so will look like this. It's a rectangular hyperbola. The point is, it will be able to take every value of y except 4. So the range is y can take all real values, but not 4. We now want to find an expression for the inverse function. So y is going to be 3 plus 4x over x minus 2, and then interchange x and y. So x is 3 plus 4y over y minus 2. Now we want to make y the subject. So I have x, y minus 2 is equal to 3 plus 4y. So xy take away 2x is 3 plus 4y. Bringing all the y's to one side, we get xy take away 4y is equal to 3 plus 2x. We've taken everything that's not y to the other side, and then factorize. So y into x minus 4 is equal to 3 plus 2x. Then y is equal to 3 plus 2x over x minus 4. So that is our inverse function. Now we could look at this and determine the domain and range from there, but remember the relationship that if we have the domain here and the range here for the original function f, then for the inverse function we have domain and range switched around. So if we go back up here, for the inverse function down here, the domain will be x. X is a real. X is not equal to 4. And you can see that that makes sense. If we look at the denominator here, x can't take the value 4. And the range is that y is a real and y won't be able to take the value 2. And that also makes sense because, once again, if x is very, very large, ignoring the 3, ignoring the 4, gives us 2x over x, which is 2. And that tells us that y equals 2 would be a horizontal asymptote.